Yeah, I'm good, doing well, thank you.
AI is going to be held here?
Yes, that's right, yeah.
There's nobody here?
Yeah, sorry, we just had a bit of a struggle with the, there was an API conference unscheduled because it's not on the university timetable.
Yeah,
so
I just got an actual email, so I went there.
Yeah, I'm sorry about that.
No, it's okay.
How are you doing anyway?
Good.
Cool.
So, are you working on machine learning or those stuff?
Sorry?
Do you work on machine learning?
Yes.
Oh, that's good. It's very actually hot topic.
Yeah, yeah.
You know, my background is mechanical engineering.
Cool.
And
Yeah, mine too.
material science. And you know, recently, I have seen so many papers on this topic.
Yeah, absolutely. It's so hard to keep up.
And actually, I wanted actually to apply for some faculty positions because I'm a postdoc here. I would say 90% of them are interested in the application of machine learning.
Yeah.
And different fields, material science, mechanical engineering.
It's going to be quite hands-on. I don't know if you have a laptop.
Actually, I was somewhere else. I forgot actually to bring my laptop.
Right.
But
Yeah.
I'm gonna actually record, and then.
Yeah, it's all being streamed anyway, so that's all available online.
Okay.
Yeah, and I'll upload it later if you want. Okay. Okay, we got people online. Welcome, come in. I'm really sorry about the room change and unexpected conference being held for some reason, not on the university timetable, so apologies for that. Okay. Cool. So everything you need is at this site. If you go to thehackerhustle.com, you can see everything we're going to be using there today. So what you want to go on is Live Now. That's what's live now. And then there's the two code sets that we'll be using today, if you want to check them out. Otherwise, we're going to be doing the programming through Google Colab. So just type Colab, first link, and then new Python 3 notebook, and this has everything set up for you. Welcome, guys. Did you all get an email with the WhatsApp link on? Check your email. There's a link to a WhatsApp chat. If you join that, that's where we're going to have some other teaching assistants. Like if you have any questions or problems or errors in your code, you can either just ask the question there or post a screenshot of it, and then we'll be able to answer that immediately. So just get that up. Otherwise, for you guys who are here, obviously just throw your hands up and I can answer questions. We'll start in just under 10 minutes to give people a chance to get here. Sorry?
What's a collab?
Google Colab is basically a live code editor. So this is where you can run Python code. It's all pre-installed with anything that needs to be there. But it's not running on your computer, it's running on a Google server. So you don't need to worry about installing stuff to your libraries. Thank you, my friend. Yeah, you don't need to worry about installing stuff to your own device. And also you can do runtime, change runtime type, hardware accelerator, and run on a GPU or a TPU for free, quickly and easily. So it's just it's really easy to just get started this way, I think. But we do have guides on, and there's plenty of good guides out there for how to get started downloading Python and anything else for your own machine. Okay. What is happening? So yeah, once you're at Google Colab, and then you're ready to code. And if you want the code of what we'll be going through, just come to thehackerhustle.com. Then you go to Live Now. That's what's live now. There we are. And then it's got the intro to Python and linear regression code, which is what we'll be going through. Hey guys. Welcome.
streaming.
Yeah, better. It's nice and on Twitch.
Yeah, good to go. There's a WhatsApp link which has which everybody's on, and just answer questions on there, and I'll explain how that works to everybody in a minute. Yeah, cool, nice one. Okay, we'll start in a sec. Everybody good? Nobody's got any questions anymore? To start with, just go to Google Colab, simple as that. We can run code there, and the other links for the actual code that we'll be going through and the workshop and the workbooks are on the Hacker Hustle page here. Okay, so you can check out those two. We'll go through the intro to Python code first, and yeah, so let's begin. So firstly, sorry about the room change. There was no conference scheduled in the university timetable, so we had to move to here, which is why we're 15 minutes late. And we'll probably finish 15 minutes later because of that. So basically what we're going to do today is we're going to start off with introducing all of you to Python, all the fundamental stuff that you need to know for that. And we'll go through some exercises, get hands-on with it, and then once we're comfortable with that, we will walk through another notebook, which is an introduction to how that relates to AI and why Python is the language to be learning if you want to get into machine intelligence. Yeah, just a show of hands. Sorry, I can't really do it through the live stream, but who's never programmed Python before? Cool. And who's never programmed anything before? Okay, good. Right, it's a good place to start. It's easy, readable, and we're here to help. So yeah, the way this is going to work, I'll be at the front, obviously leading here. There is this Twitch chat on the page here, but probably best not to use that. I've sent out a link to a WhatsApp group, which you can join by link and just leave at the end of the session. But what we found from doing so many tutorials like this is it's a really easy way for you to send messages to any of us who are helping. So just if you have any generic question, just send it there. So like this. So all these people are here. If you've got any questions, just enter it in there. If you have any, if it's too long to explain, whatever, just take a screenshot, press print screen, and then post it in there. And once that's done, I'll get a notification, and Haroon, my partner over there, will also get the notification, and we'll be able to help debug that. Yeah, and also, yeah, if you're in the room, feel free to throw up your hand at any point if anything's unclear at all. Okay. So we can get started by you can open this doc. I'll just go to it here. What's that? Okay, cool. It is this one. Right, so basically, yeah, code is just a series of instructions read sequentially by something called a Python interpreter. Interpreter is something which just goes through the code line by line, so make this a bit bigger. Thank you for dealing with that. So here's the simplest thing that you can, and the first thing that you can do in Python, right? You can print hello world. So what I'm using here is Jupyter, which is essentially just equivalent to Colab. So same kind of thing. What it looks like is cells, and each line like this is a cell. So I can print hello like that, and I just press Shift Enter to run. It runs that cell. We'll do it in a sec, and then it makes a new cell. So I can also make, see, there you go. That's what happens when you print hello. It just prints you back hello. Yeah, so it consists of a bunch of different cells in Jupyter, which is really easy to download. Just type, if you want to get onto this now, they're literally the same thing. So you can just type Jupyter with a Y, and then get this installed. It just consists of different cells like this. This is a markdown cell, so you can put text within code, and that's why it's a really good learning resource, and it's a great way for us to for us to teach through this. Is that large enough? Can everybody see that? Cool, good. This is a code cell where you can write Python and execute it. This notebook is running Python 3, which has slightly different syntax to Python 2. That is the way it's written. It's slightly different. For example, in Python 2, this print wouldn't have brackets. But Python 3 is the latest version. It's the one where all the support is now, and it's the one with all the most advanced libraries and the stuff people are working on. So this is what you want to be using now. So has everybody managed to run in Colab print hello world? Anybody not managed to? Okay, we're good then. So the next thing we can do is similar to Markdown, but in actual code. So if I was using PyCharm, for example, an actual code editor, I wouldn't be able to put Markdown, but I can put comments in my code like this. So we can put a hashtag, just means ignore this line. Tells the interpreter to not read that line, not try and execute it. It's just for our benefit to be able to look through and understand what's going on. So yeah, here I wanted to know what was happening in these lines below. I can say, yeah, this one's printing hello world, and this prints the operation 1 plus 3. So note here that this is another thing we can do with Python, is use it like a calculator, like this. Arithmetic works mostly just as you'd expect it to, so obviously that prints 4. That's like evaluated and then printed. And that leads us to variables. So in Python, you have variables, which are just data storage, and those variables can have different types. So for example, integers are whole numbers, that's how you'd store a whole number. So, that's the data type of what this is here. You can have floats, which are any real numbers, not necessarily integers. Boolean values, like true or false, they're binary valued. Strings is a list of characters, and lists and dictionaries. So I will just delete these and we can code them by hand. So an integer, we could say something like x is equal to 5. That means that their x has been assigned to 5, which is an integer. Then we could say y is equal to 5.6, and then we can say print type type x. So this is a built-in function, as is print. So what that means is that you don't have to use any libraries or anything. Like these functions are just readily available in Python. And so then we'll copy that as well. Put the same thing and see why. Okay. If we run that, it returns these two things. So it's printed that type x is class int, and type of y is a float. So what else? So I just mentioned these built-in functions. If you want to know what they are, and then you can just go to the docs. So you can just type Python built-ins, and then you'll come to this link. Not that one. This one, for example. This is one example of documentation which has all the built-in functions of Python. So you'll note down here, there'll be print. So print is a built-in function, and this tells you what it does. Prints the standard output device, which is just the console here. So if you have, if you want to know what you can use in Python without having to install anything else, then you can just come to here, or the Python official docs. I'm not sure what they are. Just go to documentation. There you go. Look. So Python standard library. This is the official docs of Python. And throughout this tutorial, if it's your first time coding, I'm just going to be doing what I would do if I were you trying to learn to code, which is I don't understand something. I'm going to go to the docs and I'm going to look at it. Okay. So here's a better layout of all of the built-in functions for Python. And you can click through each of them to see what they all do. But print, pretty important one. Print an object. What else? We can sum things up. We can do all this different stuff. So that's just the different things that I'm doing in this Python code here. So yeah, type and print are both built-in functions. So what about other kind of variables? So Boolean, let's say, let's say we make a new variable called v, and then we can make that true like that. And so that's one Boolean value. So it can either be true or it can be false. And then we can print again type of v there. And you can see, okay, that's another type bool. And you can do the same for these list and, well, I'll go over those actually. So let's have a few more. Let's say our variable s is equal to hi there. Then that's going to be a string. So that's what a string looks like, which is just a string of characters. So that's that. What else do we mention up here? A list, okay? So say list L is equal to, a list can just be is literally a list of different things. So the way we indicate a list is with square brackets. So let's say we have a list, and these lists contain, they don't have to just contain one data type, they can contain different ones. So it can contain 4, 7, hi, true, like that. That's a list of different objects, and you can then, and then that looks like. So if you printed the type of L, you'd get list. So what else we got? Let's have a look at a dictionary. So a dictionary is something which maps one thing to another. So we can say my dictionary D is equal to, the way that we write the syntax is with these curly brackets. So let's say we wanted to map the letters of the alphabet into indexes. So what we do is we write, okay, what we want to, the key which we want to map to, with this colon, to some value. So let's say we'll map that to 0, comma, to separate the different items in this dictionary, and then we'll say B maps to 1, and then C maps to 2. Okay. Now that works. Okay. So now we can say, with both of these two objects, what we can do is we can get the different items from them. So with a list, the way that we can do that is by giving an index of the element which we want. So let's say we want to get hi out of this list. What we need to do is write, so let's print it. We'll print the list, and then we'll give it an index. So the way that you do that, to index a list, is give square brackets, and then the index of the element that you want. And what to note here is that Python is 0 indexed, which means that if I type L1, print that, what we'll get is 7. 7 is not the first element. 7 is the second element. But Python's 0 indexed, which means it counts 0, 1, 2, 3. So if I want hi out, I'm going to have to index this with a 2, like that. And to get the first element, it's actually the 0th element in Python. So to print that, I get this 4. I can delete that now, we understand that. So yeah, I think we'll get on to more complex list carbs later. So yeah, there we go, we can print the 4. Now with the dictionary, let's say, okay, we've got, whatever, for some reason we want to do this mapping. Now we can basically do the same thing. So we'll index the dictionary, D, with some key, and that will map it to the associated value. So if I pass it the key of B, what's it going to print? 1, right? Run that, and this is the value which is mapped to from that key B. Okay. Yeah, so that's basically the major types that you need to know of in Python. That's how they all look, and we'll get onto why we have them and more complex stuff you can do with them in a minute. Okay. So yeah, we can do things like this. We can add strings together, and what that does is, so yeah, I've cut that part off earlier. We can say name is equal to Claire, and then we can print my name is plus name. So it adds these two strings together and just concatenates both into this thing which says my name is Claire. We can also, so let's try, yeah, so obviously if we have, let's try and do that. So we can do print x plus y. So we defined x plus y in the top. run that and we get 10.6. Okay, that was 5 plus 5.6. Yeah, so this is just some simple operations that we can do with variables there. And now, yeah, so just to highlight, if we try and do something like print name plus x, we get an error. This is the first error we've seen, so let's just talk about how to read it. Get these lines. It says, what kind of error occurred? There was a type error. So what does that mean? Let's have a look at the docs. Okay, look, so here's all the different types of errors you can get, and there's loads of different ones. For example, look, this one, key error. What happened? When is that raised? That's raised when you try and you try and index a dictionary with a key that's not in there. Okay, and there's when you try and try and index a dictionary with a key which doesn't exist. What did we get though? We got type error. So this is raised, which means the error comes up when an operation or a function is applied to an object of an inappropriate type, right? So what's happened here is we've tried to add a string and an integer, and it's just said, so we've had type error and it's told us it must be a string, not an integer. Either way around would work, but it's just throwing that one. So yeah, that's one kind of error we've got there. Any questions so far? Yes.
So just when it's my name is, and then there's a colon,
Mm-hmm.
is that supposed to be good?
This apostrophe, yeah, it's just like it's just a quote mark. You can use single or double quotes. But if we remove these, right? Let's have a look. What's going to happen? Then we're going to say an invalid syntax. Well, that's because it doesn't expect there to be spaces like that, really. But if we just said, let's say we said name, then what we're going to get is like name is not defined, right? Because this isn't in strings, it thinks it's a variable, but we haven't called anything name, right? So we could say, then we could say this would be a kind of pointless thing to do, but we'd say name is equal to the string name. Then we'll run that, it'll print this, which is this line here, but then we still get the type error down there. Okay. Cool, right, so let's move forward. Again, any questions at any point, throw them on the WhatsApp or just throw your hand up if you're here. Okay. Cool, so this is, what we can do is we can say, okay, let's say age equal to 21. Maybe I did this 2 years ago. No, I'm joking, I don't think I put my real age. So we want to print, my name is, my age is age, right? My age is 21. But we could also print my age is plus age, right? That might be something we want to do. What's going to happen when we run that? We'll get type error because it must be a string, not an integer. So this value here is an integer, and it says that it should be a string. So what we can do is called casting. So casting is where you take one variable, you basically change the type of it. So we're going to cast this integer into a string with this Python inbuilt function, string, okay, str. So that's going to take an input and convert it into a string. So then we'll be able to print that, right? Invalid syntax, yeah, because I forgot the bracket there. So we'll run that. Note that it doesn't separate them automatically. You need to put a space there if you want to run that. But these two are equivalent in that way, okay? So let's say we want to print the age of a person in 5 years by adding the age, adding 5 to the age variable, but it's taken as a string. Then, so yeah, say we took an input, we took that age we wanted a number, but we took it in as a string. Well then, so the type of age currently is string, and we want to add 5 to it. We're not going to be able to do this right now. So we'll run that and we'll get an error, which says, again, must be string, not integer. But we can do another type of casting from a string into an integer by using this inbuilt int. So that takes in a string and converts it to an integer where that's applicable. So let's comment out that. That runs nicely. But what if this was like that? Okay, so if this was a If this was a decimal, then we would have another error here. So value error, invalid literal for int. So it basically means I want an integer, not a float, which is what this is, and throws us that error. Okay. So what are we going on to next? To lists. Okay. So here's another example of a list. And I'm just going to delete these so we can go through them. Okay, so if we print my list, which is this variable here, it prints us, I have to find all these variables up there. Let's say hair length is equal to 3.5, and then name is equal to Harry. Okay, now we can run that, and that's our list. But what if we want to get certain elements of that list, right? So I said before, we can do single item indexing. So let's say I just want my name. Well, actually, let's say I want my age firstly. So we can print my list with when we want this item. So we want index not 0, not 1, but 2. So run that, get 19. That's my that's the age which is defined there for some reason. Now let's say we want the first, second, and third item. So we can print my list. We want all of them up to the third one, right? So that means up to the second one with 0 indexing. But the way we can say, so instead of saying like print my list 0, my list 1, etc., we can just go all the way up to 3 by using this colon. So if we run that now, what this syntax says is that I want everything before and up to 3. So and the way that this slicing, as it's called in Python, works is that we'll go up to but not including this index. So this index 3 here would be the 4th element in the list. It will be this one, but we haven't printed hair length here. We've just printed items 0, 1, 2. So what if we just wanted the second and third items? Then we could go from 1 to 3 like that, run that, and so that's just how slicing works. Okay, so we want from and including this element, the element of this index, up to, but not including this element index. If we wanted all items in the list except the first one, then we could do the opposite of what I did before, and just go from the first one up to the end. If we don't specify an argument there, if we don't specify a parameter there, then it will go all the way up to the end. So there you go, from 2 up to name. That's what we get like that. Okay. So print the second item. Print from the second item to end. So let's print. So that would be. We could say 0, 1, 2, 3. But what if we didn't know the length of the list? We just knew that, well, it's always going to be the second last item. Then what we could do is index the list with a negative index. So for this line here, print final item in the list, what you do is put -1. So if we run that, you get the last item in the list, name. But if we want the second last item, we can do 2. And we can also do slicing in this way as well. So let's say we wanted from 2 up to hair length. Well, we could index from 1 up to -2. Well, that's up to but not including. So we can say up to but not including the last element. Okay? And that prints us that here. So we've sliced out everything beyond the first item and up to but not including the last item. Is that clear? Any questions about slicing? Okay. There's also another thing we can do, actually, which is we can give an additional argument to that slice, and we can say, okay, let's say, I think that's the syntax, yeah. Okay, cool. So what I did here was I added, so originally, well, first things first, if we printed this, it would give us all the items in the list, okay? Because we said, well, there's no argument in the beginning, so from the beginning, and there's no argument at the end, so up to the end. That's the whole list. And we could print, 1 to -1 like I did before, and get the last element. And then what we could do, say we had a longer list, then what we could do, actually I'll just make this longer for demonstration. Okay, we can add another argument. So we've got this colon here, which says from everything before it is where we want from, and after it is where we want up to. And if we add another colon, we can say what step size do we want between these indices. So if we put a 2 there, then we're going to get these items, right? So we get 2, hair length is 3.5, and then what is this? And then 3, and then 6. So what that's done is it's gone from the first item up to, but not including the last item, with steps of 2. So it's gone from here, it's got the item 2, it's got hair length 3.5, it's got this 3, and then it's got this 6. Is that clear? So they're the 3 arguments you can use in list slicing to just get different elements of what you want out. Maybe another thing to note here. Okay, let's just add another cell below. We can say, let's say my string is equal to hello world. And we can index this string like a list. So we can say print my string, let's say 2, and that's going to print us L, which is essentially treating this string as a list where every character is a different item in that list. So H would be index 0, E, 1, L, 2, which is what we got. So what we could also do, let's say we just wanted the world, then we can index that from -5 up to the end, okay? And we can get that out. And we can do just the same kind of slicing that we did on these lists as we did here, okay? So let's just play with another thing as well. Let's say we did want to split this string up into a list. So this is kind of a useful thing. I end up doing it all the time. What we could do is we could do print my string, and it has a function, right? So this string, it can do certain things, right? And one thing it can do is we can split it by giving it a character at where to split it. So it has a function called, and I'll explain that in a sec, called split. And so the way that we get that function from this string, which can do certain things, is we give it a dot. So if we say we have this object, as it's called, it can do certain things, and we can access them by using the dot. So we can get the split function, which is something it can do, from it, and then we can say split it. The argument it takes is what shall I split it at. If we run that, we'll get this list returned. And so this is just split them up by looking for this delimiter and then breaking them at that point into a list. Okay. So again, if we want to look at what those different functions are, we can go to the docs. So we can just say Python string functions, or another word for functions, more common one in programming terms, is methods. So let's have a look. Python string methods. Looks like these are all the different methods which we can use on a string. So there's loads you can see. So this is another useful one, strip, for example. So if there's white space at either end of the character at the end of the string, and you do myString.strip, it will remove that white space. What else we can do? We can do replace. So .replace, it takes in 2 different arguments. The first one is what you're looking for. The second one is what you want to replace it with. So we'll get onto functions in a second, and that will become more clear. Well, are there any questions so far? Does everybody understand how that works? Okay, cool. So here is an example where we've got 2 lists, vec1 and vec2, i.e. 2 vectors, and we can make them into a matrix by just putting these lists inside another list. So when we make this matrix, what you'll see, what it is, it's a list of lists. Like I said earlier, a list can have any kind of object type in it. In this case, it's a list of lists, which is essentially what a matrix is, right? And then we can index this list of lists, this matrix, with, well, we can index what items we want from the bigger list by using a single index. So this here, we get the first element from the matrix, that'll get us this part, and that's what's printed there. But we can also index the rows and the columns by indexing what we got from that matrix. So this returns us a list, and we know that we can index this list with another index by just using more square brackets, right? So to do that, here we've got the first element in the row and the first element in the column, but really zero indexing, that's the second element in each of them. So yeah, okay, cool. Understand that? Simple way to make matrices in Python, but as we'll see, like that's not how we're going to do it. Yeah, so here we're getting to more functions of different objects. So just to explain, firstly, I think Python is what you call an object-oriented language, which means that every different data type is an object, and an object has two things. It has attributes and it has methods. Attributes are, you know, detailed about it. So in case of the string, like an attribute is like what it says, and it has a method or a function which are things it can do. Like it can do the split method, or it can do dot lower, and that would lowercase it all, those kind of things, right? So here we've got my list. My list is a list object, and it has a function called append. What that does is it adds the argument to the list, okay? So we had my list up above, it was this one, and it ends in a 6. But then if we append new addition, what we'll get is this. So it's had new addition appended onto the end. There is another method. So print mylist dot pop, and pop is another function. What that does is it takes in an index and it pops off the element from the list. It removes it from the list. So if we print that, so it returns the element and then it removes it from the list. So here, right, we had this list which starts with a 1. If we popped off the 0th element, that means we get this 0th element, right? But now, if we print my list, you'll notice that it doesn't have, see now I've popped off the 2, and now it doesn't have the 2 anymore, okay? And if we keep doing this, it will keep returning us this element and then removing them from the list at the same time, okay? Yes?
Can you do minus.pop 0 without the print?
Sorry?
Can you execute minus.pop bracket 0?
Minus.pop 0, do you mean putting a negative index in here? You can do that.
Just without the print part.
Yeah, so it'll still execute without the print function, but we just won't see it. So now we're going to get 19 at the front. It'll pop that off, return it to us. So we'll see 19, and then the list will just be 3.5 onwards. Okay. Yeah. Mm-hmm. Yeah. Okay. Cool. So yeah. Sorry. So yeah, because I popped off the last one there. Without any arguments, it removes the first one as well. Okay. Okay, cool. So now we've looked at objects, we looked at some simple functions of lists. Let's just have another look, another one. So let's say, we'll say L is equal to mylist.reverse. And we'll print L. Okay. Yeah, I don't think that returns anything. Okay, look. So, sorry, just to remove that. Let's just start again with the my list to make it a bit clearer. there's a list. We append new addition to it, and then in this case we call the reverse function, which reverses that list. Okay. Now, see what I didn't realize here, right, was that my list dot reverse, this function, it doesn't return us anything. It just reverses the list. So if we try and print L, what we'll get is none. See, this function, it just did something on the list, but it didn't give us anything back. So we'll see how that works in the lower level when we go into functions now. Okay, cool. So here's just what I showed earlier. Dictionary mapping between key and value. So here we've got the index to name, index that with 0, and it gives us John. Okay. Question? Yeah.
Just wanted to ask 2 questions.
Go.
The first is what's the point of having 0 index? So I'm sure there's a good reason.
Let's have a look. I can't remember exactly right now. Haroon, what's a good reason for 0 indexing?
Is there a way we can change it?
Yeah, if you want, you can just add a 1 to your index. So you could be like,
Because you know, whenever you do a matrix operation, or if you're referring to a matrix of numbers, and you want to refer to the element in position 3, 4, 3, column 4.
yeah.
It's just I can't see it seems just an unnecessary thing.
Yeah, so
minus 1.
Purely historical,
Yeah,
as in mathematics.
yeah, I don't really think there's a good reason for it.
Computer scientists, because you have the 0 at the beginning. If you list all the numbers, you list them 0, 1, 2, 3. And then where else do you put the 0 in your list of numbers?
Mm.
You have to start somewhere. You can't put it behind the 9, because that would be 10. So it's there. So they kind of always have the 0 as the first element of all numbers. So they, computer scientists think it makes more sense.
Thank you. There we go. So computer scientists think it makes more sense. Where you're going to put the 0, if it's not before the 1, you can't put it after the 9 because it will be like a 10. So we 0 index things in Python. Okay. But yeah, good question. I don't really know like a really good reason for it. So any questions up till now? It's like basic Python data types we've looked at so far. Just played with them, played with some of their functions. Now we're going to get on to actually how do we make our own functions. So let's make a simple function to add 2 numbers together. The syntax for this, it looks like this. So we can say def, which means define. I'm going to define a function now, okay? I'm going to define a function called add, and then we give it brackets. And in the brackets are the arguments which this function is going to take in. So let's say I'm going to call the first argument it takes in A, and the second one B. And then I'm going to write what this function does, okay? But firstly, what we're going to do is we put this colon here, and this means that Python is now expecting an indented block. See, when I press enter there, I didn't start at the beginning of the new line, I started indented like this. So now we're going to do, let's say, C equals A plus B, and then we're going to do return C, okay? So, and then in this line, what's happening is we're calling that function. So we're getting the function add, and we're actually passing in 2 real arguments to it, 5 and 10. And then what happens is that we'll get C, which is 5 plus 10, and it'll return us that C. So that C comes out of this function, and the sum is assigned to it with that equals, okay? So run that, and we'll get 15. So Python is sensitive to white space. So if we write that, it's not going to work. Expect an indented block. And it's understandable because, well, if you write this, like, how do you know where the function ends? It's not like other languages where there's certain like syntax to specify that. It's not really clear. Okay, so yeah, that's how you can define a function. Really simple example. We'll build some much more complex ones later. They don't have to return anything like this. So in this case, we don't have a return statement, but it just prints the addition of those things in the function. Okay, but we won't actually be able to assign anything to that. So let's say like s is equal to that, and then we'll print s. This is what I showed before, right? So nothing comes out of that function because it's got no return statement on the end. We could return x plus y, and then this would take a value. But without that return statement, then nothing comes out of the function. So what s is assigned to when we print it is none. And that's the unassigned data type in Python, none with a capital N. So that's already predefined as well. I can write none. It changes color nicely to highlight what's happening, because it recognizes that that is something valid. It's not going to throw a name error like it would if I put none with a lowercase. Okay. Right. So another thing, functions don't have to take in any parameters. They can just have no arguments. And then see when we run this one, what's happening is just goes in the function prints cheese. One thing to be clear about is like, even if it has no arguments, you still need to put the brackets, right? If I just put PC like that, it's just going to show me what that function is actually. So it says it's a function in this file, but we're not actually calling it like we are when we put the brackets around the end. Okay. Cool. Any questions about functions? Good. How's the chat looking? Cool. All right. So if statements and logical operators is what we do now. So we have all of these different type of operators in Python. So I think it's fairly easy to understand without having to walk through them. But if we assign some variable x equal to 5, some variable y equal to 10, then we print x greater than y. That's going to print false, because x is not greater than y. If we print x less than y, it's going to print true. X equal to y, false, because they're not the same. So here's a more interesting one. In Python, we can't say x is equal to y, because that would be an assignment. We'd be making x equal to y. But actually what we want to do is check for equality. So the syntax for that in Python is a double equals. So is x equal to y? That's what that means. If we put that, we'd be saying set x equal to y. And then we'd get an invalid input to that function. Into that function print. But when we run that, it's fine. What if we want to check if it's not equal to? The syntax for that is exclamation mark equal. So in this case, x is not equal to y. So the fourth of these print statements will be true. Okay. Is x greater than equal to y? That's going to be the same as greater than in this case, and less than or equal to as well there. So they're basically all a bunch of different operators which you can use in Python. Any questions about those? They return you logical operators, true or false. They return you Boolean values, true or false. Okay, cool. So now we have them. We can use them to do something more interesting in if statements. So here we're saying if x is greater than y, we've got a colon, which means go into this block. So we'll only run the code in this indented block if x is greater than y. Okay. So one thing you do is just put a random undefined variable there, and it'll break the code at some point, so you can just see what happened before that. So x is not greater than y, so nothing happened. I can put this, so I can put true there, which is essentially what that, it was evaluating to false, but if I put true there, it'll run x is bigger, okay? It'll go into that block and run this piece of code. Similarly, if I put false, it won't run anything before I get that break there. So we can put back x greater than y. Okay, nothing runs. So we can use this if statement like this, and we can also then say, okay, well, if that didn't happen, what else do we want to check? We can say, if that didn't happen, else do this. So if x is greater than y, print x is bigger, else print y is bigger or equal. Okay, so we're going to get y is bigger or equal. Just to remind ourselves, print x print y. Okay, so x is 5, y is 10, and we've gone through this, right? So we said if x is greater than y, print x is bigger. Well, x is not bigger, so that didn't happen. Python didn't go into this block and run that code. We said else, print y is bigger or equal. Okay, so y is bigger or equal. That should be greater than or equal to then. So we went into that block and ran that code. And we can also add else if clauses. So we can do if this, then this, otherwise this. Or we can do if x is greater than y, print x is bigger. Otherwise, if x is equal to y, then print they're equal. Otherwise, y must be bigger. Okay? So they're the ways you can control your flow in Python code and make it do different things. Okay. Any questions about if statements, if else? I hope you're implementing this yourself and writing these because it's obviously the best practice to get hands-on with it. Okay. So another kind of thing we can do is a loop. So in this case, what we've said is that x is equal to 0, and we said while x is less than 5, colon, so go into this block, right? Go into this block and print me x. And then in that block as well, add 1 to x. Note as well that this is a shorthand for x is equal to x plus 1. You can just say x plus equals 1, similar to other languages. So when we run that, it prints us 0, 1, 2, 3, 4. Then x is added. Then 1 is added to x. X becomes 5. This then evaluates as false. X is no longer less than 5, it's equal to 5. So it doesn't go into this block, and it just stops. Okay, we finish that code. That clear? Cool. And then we can have these really useful loops, for loops. So we'll say for k in range 5, print k. So what's range? Let's have a look at that. So it actually returns us range 0 to 5. Python range, let's have a look. Returns a sequence of numbers starting from 0 by default. But it actually returns us this range object. So it's not like a list which we can index. It's actually what's called a generator. So if we said, well, like we do in this case, for k in range 5, it gets these numbers from 0 to 5 as we go over that list. It doesn't actually return us a list, which is useful because say we wanted to do for k in range, you know, in just a huge number, right? I'm just trying to think of a real life example, number of blood cells in this sample that you want to test on, then that would be huge, and you'd have to make a list that long, and that would take up all your RAM, right? So you don't want to do that. You just want to generate them as you go, which is what a range, which is what a generator does, which is what the range function returns. Okay. So this range again is a built-in function for Python, and that's how that looks. Cool. So, and you can basically with a for loop, what you can do is go over anything that's iterable, as it's called. So things which are iterable are like generators. So you can go over this range. You can go over lists. So a list isn't iterable. So it just has each item in there you can iterate over. You could do the same thing for a string, like I said, because it gets treated like a list of characters. And so, yeah. So for example, in machine learning, like what we end up doing a lot is have like different batches of data in a generator or a list, and then we just iterate through that list and pass them through our model and train the model. And that's what we'll see, we'll do in a bit, okay? Cool, are there any questions about that? All right, good. Now we'll get on to something quite cool. So classes and objects. So sometimes what we want to be able to do is just write one piece of code which can be reused over and over again for maybe like many of the same type of thing. For example, if you've got like players in a game, they're all really the same. They all have the same attributes and methods. They can, they have the same properties and they can do the same things. But you don't want to have to write like, you don't want to have to write loads of different functions to control every different player, that kind of thing. So what we use is classes. And classes are basically templates of code which we can reuse and make copy instances of. We'll see that in a sec. Just to make sure I haven't missed anything. Yeah. Okay, cool. So let's just implement this one here. So we're going to say that I want to make a class, okay, right? I'm going to make some reusable piece of code, which I can then create instances of. So we're going to make a class called car, and yeah, the best practice syntax is to write classes with a capital, starting with a capital letter, and then what we're going to do is we're going to firstly define, okay, well, when I create a car, then what do I want to happen? So what you have to do is make something define a function of this class called $_init, $_. And that is called a constructor. So what happens when you create an instance of this class is that this function runs automatically. And it's basically like, well, we know that we know cars, they need to have certain properties, so when I create an instance of a car, I need to assign them straight away, okay? So what we're going to do is we're going to say that, okay, well, when I create a car, maybe I want to know what brand it is and what year it was made, okay? There's like, I need to know those things to create the car, otherwise it's like, well, what is this I'm creating, okay? But we need one more thing. So this function could be, it could be referring to any of the cars at the moment, right? But it's already in this class block, and it knows that it needs to refer to a specific instance of this car. Okay, and the way that we tell it that is by putting a variable here, usually called self. You can call it anything, but don't call it anything but self. Self means that I'm referring to this instance of the object. So this will become more concrete when we just go through things here. So we're going to say self.brand is equal to brand. What does that mean? That means that when I create this instance of the car, so I'm going to run this initializer function, right, this constructor, and it's going to set this instance of the car class's brand equal to the brand, okay? So we're just using the dot again here to get either a method or an attribute from that object, and in this case it's an attribute because it's not a well, we're just setting it as something which isn't a function. Okay, so now we can actually we can create an instance of a car, and you see what I'm talking about. So we'll say like my car is equal to some instance of a car. Okay, so that's me making, okay, this car is an instance of a car. Okay, is that clear? All right, but then we need to pass to that car, what's the brand? So we'll say Mercedes, and we're also going to pass it the year. Okay, so we'll run that, and that seems to work. And then we can access the attribute brand of this car. So we can say my car dot brand, and that will print us Mercedes. Okay, and this kind of thing is what's happening when we do like my list dot append. It's like the list is a class, so there's a class list, which means you can make list objects, and inside that class you have a function which will be def append, and then in that block it will tell you what to do when I call the append function on the list. Okay, so just to fill this out more, we'll say self dot year is equal to year, and we're going to make some more functions here. So this was setting it up. Okay, so now we've created a car, we know what brand it is, we know what year it is, and then we can say we can say def start. All these functions need to take in self because they're referring to this instance of the car class. And then in this one we're going to say if self.year is greater than, let's say, 2000, we'll say self.state is equal to moving. Okay, and we'll say else self.state is equal to stalled. Okay, so when we try and start this car, we're going to check like how new is it. If it's new enough, it will start moving, and we'll assign that to the state. Otherwise, we'll say it's stalled. Okay. So then we can say we've created this car. When we instantiated it, this run by default. Okay. And then we'll say my car dot start. Okay. What else do we need there? Well, if we run that, what's it going to print? At the end of this, we'll put print self.state. So what's going to happen? Well, it didn't run that, right? But that's because we didn't call this function. So let's just call that function. And then we can say the status is moving because my car is newer than the year 2000. Okay. But then, like I said, the point of this is that the car object is reusable. So then we can say your car, your old ass car is some Nissan from like 1999. Now what's going to happen? We're going to say your car, or ucar as I've called it, dot start, and it's going to print the status of your car. So mine's moving, yours is stalled. I'm sorry. And so that's because we created this other instance of the car where it's older. It's older than year 2000. So when we did your car dot start, it checked how recent it is. It didn't go into this block because it's not more recent than 2000. So it stalled, unfortunately, and then it printed that to us. Okay. So people understand how classes work now. Okay. Cool. All right. So that's basically what we did down here. Just a bit more clear of an example. If you want to take a look at that. So we'll just have like 5 to 10 minute break. Ask any questions you got, and then we'll do some more practical stuff with that. But yeah, well done for doing that, because that's like basically all the fundamental stuff you need to know to be able to program in Python. It's just about practice, just about keeping doing that. And soon enough you'll be able to move on to doing much more complex stuff, as we'll be doing over the next few weeks. So if that was interesting at all to you, or you want to get into AI, then just keep updated with us. Cool. Yeah, if you've got any questions or want to chat or whatever, just come talk. Harun and I are available, and the WhatsApp's about as well. Yeah, just shout if there are any questions. But yeah, thanks for doing it's an introduction to it's basically like so it'll be like it'll be an implementation of linear regression in NumPy. Okay, alright, yeah, that'll be alright. It's just like the groundwork for but like if you want on next week, like it just built on this. Yeah, we'll be running them like just continuously. Yeah, this is streaming now. Yeah, and put on YouTube. Yeah, that's not like anything else like
Harry, where's the link for that?
For what?
The tutorial.
Yeah, just go on thehackerhustle.com, go to live now, and then there's a link on, there's a button at the bottom which is like intro Python code. It's all that. Good, I like what you're passionate. It's not, I don't think we're going to be a series, but like, I love teaching. I want to get like more people involved. Build cool stuff. So we're just going to be running progressively more advanced workshops, more and more interesting things like continuous, basically like summer, early summer. This is kind of like the introductory stuff. It's all filmed, so we'll be involved later. Yeah, next week's going to be more comprehensive than we'll do today. Today's just going to have to get the skills. After that, we'll do like an intro to deep learning, and then we'll do like some interesting stuff like deep learning, computer vision. So yeah, it's not really a series, I say. Probably next week. Yeah, is this a good time? Pretty cool. Yeah, we'll send out feedback.
I think so. I don't think I can find a course that needs to I mean, unless you decide. I just never mind. Yeah, it's also more
Get hands on.
less about
And like the stuff we'll do in a second is basically what it's like so easy to build on. It's basically state of the art stuff. Yeah, it's really interactive. It's all in Eventbrite now. Eventbrite's great. But we'll be building out this site, so it's got like more functionality. So there'll be like maybe like exercises that you can do with one on the site, stuff like forums to discuss. We want to build it into something. I mentioned goals like, hey, I work with this project, then people who are specialists in language processing. Yeah, exactly. So we've got a community around it because I think a lot of people are interested in it. It just seems like just obvious to do, right? So people are interested in it. It doesn't seem like people's doing a good job. Something like I would think. Make it just before we're badass and hackers. Just build stuff from it and build businesses and products. And we're really yeah, it's a good site actually. I play around with like forum. Yeah, I'm just like oh, right, yeah. Cool. Oh, that's nice. Yeah, I didn't know. That's like data science, it's all about challenges, it's not really about like teaching people to get data. Yeah, it's kind of hard to check it out. But yeah, I mean, I don't know if it's an experiment, I don't know, see what happens. The only idea, awesome. Yeah, that's what it is. I thought, yeah, I mean, obviously, personally, I'd love to be doing more advanced stuff now, it's like, it's so important.
They're quite sensitive, so it's a lot of
and that's like, you know, it's like teaching them fish. So I think
like, yeah. So it's kind of nice. I mean, it's not like it's my own biology.
Yeah, definitely. What's your background?
Yeah, I mean, how cool is that? Yeah. So, it is like, basically, your research is, you don't care about your weekends or whether it's late or not, or whether what your time
Oh, you
is.
recommended this?
So,
Yeah.
yeah,
Okay.
so don't take
That's
one,
good.
and I was like, oh,
Talking about getting the word out.
and you're on the job, and they realize.
You did a GANS lecture last week, actually.
So
So
you just say,
yeah.
later, and.
Oh, I've recorded it actually. It's on YouTube. Yeah, it's on
And
YouTube.
one day,
Oh,
it
could be better. Like I said out there, I did this. But yeah, if you just go over the Hacker Hustle on YouTube, you can find it there. Yeah, let me know. Also, I'll shout out at the end, but if you're on the Hacker Hustle website, there's a button that says Deep Learning Office Hours.
I think I could
Press that,
probably get away with it.
just fill in the Google form where it's like, would you like help with,
Yeah, it's super easy and like,
what's your email?
I mean, basically, same thing in one way, I went to count like, but I think it was that.
I'm doing it for weeks, but like, and you always come to me like, hey, I've got this problem. I'm like, you do it. Okay, I'm gonna see them. Yeah, well, I'm actually and lost. Was that was citing this January? A year ago, yeah.
A year ago end of January.
A year ago, it's like how people came along with students, and then we just, we started teaching, people from all over the place. We started something, just to basically do the ML Society at the communities, but it just became like, working something about projects and stuff, and just like, cool software, and that's not what it's about. There's a lot of things about pay us $5,000 for some more data science. Like there's a lot of good data sets out there, right? There's like big data sets built with good generative models, even whatever. And it's just a question of time and how good you want the model to get. Like I can get like that's a really good laptop. I have my old laptop, but I can get like decent GAN results in like an hour or something. You know, on a similar data set like fashion index. But it really depends on like okay, you know, this generation, is it color, what's the size of the output?
There was like a more
yeah, I mean, but then again, like, you know, build like the internet from scratch, build GPT,
if you're interested in one, in the other.
that's actually something we're teaching. Talking about guess, build like a back end of a startup, and that's like that's really useful.
Why did I take my years to get me but right now probably not. So what
I'll send out feedback into this.
Yeah, sure. I'll send you it in June.
Cool, I'm dealing with this now.
Because you're starting to like the summer.
Okay, we're back. Alright, everybody feels comfortable. They know Python now, yeah? You can all program Python, alright? Okay, cool. So now we can. All right, who's here? Yes, the video is saved. Haroon, can you check that out? There's some comments on the chat on Twitch. Okay, cool. So now we're going to go through a simple basic model called linear regression. All right, we're all ready. So basically, one thing that we want to do in machine learning, well, basically the most general thing you can do in machine learning, and basically every problem can be formulated as mapping an input to an output. Okay, and the way that looks mathematically is you want to build a function which takes in your input and spits out your output, and that can be anything you want. That can be image to bounding box. That can be like video to classification. It can be audio to the text being said in that sentence, or it can be something as simple as we will do now, a vector of inputs, features about an example, to an output prediction about some value of that example. And so one model that we can use to perform that mapping would be a linear model. And the way that we can train it is using something called linear regression. So, yeah, okay. I wish I had more pictures in here, I'm sorry. Basically, linear regression is where you take a weighted combination of your inputs. So let's say, I think we give here, yeah, we have the problem of predicting a house price from the room, from some features about that house, right? It's the canonical example for starting off with AI with linear regression. So we have a load of houses, right? And we know some features about them. We know perhaps the number of rooms in the house. We know whatever features, the number of doors in the house, the number of windows, the age of the house, the age of the person who lived there before, right? So in that case, I named 5 features, and what you'd have is those numbers in a vector, okay? And every vector would be one example for that data set. And so you'd have those features, but you'd also have in your data set a label for each of those features. So you'd have a number, which is, in this case, the price of that house, right? And so we're trying to learn now a mapping between those things, between that 5 vector, or however many dimension it is in this, to that output price, right? And the way that we're going to do this with linear regression, it's a really simple model, but it's just to get started with understanding the different components of machine learning. What we're going to do is we're going to make a weighted combination of those inputs, okay? So that's what this equation here looks like. So what we're going to have is we're going to have a weight, that W1, I don't know if I can make it larger. Yeah, so we got weight 1 multiplied by feature 1 plus weight 2 multiplied by feature 2 all the way up to the nth weight multiplied by the nth feature, okay? So every different feature, all of these x's up to xn, represent something about the input, right? And the weight represents, well, how much does that feature contribute to my output? Is that clear? So for example, that's called a linear combination. We're making just a weighted sum of the inputs. And what we're going to try and do is learn what those weights should be so that the output is a good prediction, right? So consider this. Consider we have a feature which is the number of rooms in the house. Well, the number of rooms in a house, we can be pretty confident that it's going to contribute positively to the output, right? To the price of the house. The more rooms it has, the more the house should cost. So if that's feature 1, number of rooms, we can expect a good value for W1 to be positive and large, okay? Let's say we have another feature, which is the age of the house. Well, the contribution of that feature might actually, the larger that feature gets, it might make the house worth less as it's older. So you could imagine that if that's W2, if that feature age of the house is x2, then w2 might be negative. And as another example, let's say, as I said, one feature of the house, say xn, is the age of the person living in the house beforehand, right? What kind of a value is that going to have? Well, it doesn't really matter, right? It doesn't really matter how old they were beforehand. Like, that's not going to influence how much the house is worth. So you can imagine then the weight corresponding to that feature might be around 0, right? And so in that case, what we'll see is that a house with lots of rooms and is quite new will be a positive, will be worth a lot, right? And so, yeah, that is just a linear combination, and that's all a linear model is, right? We're making a weighted sum of the features to predict the output. Is that clear? Any questions about that? That's the input-output question.
Is it still a linear combination if the weight isn't a single number, like it's a formula of some kind?
Yeah. Well, if your weights were a function of the features, then you'd be getting nonlinear combination when you multiply them together. But in this case, that's not what we're doing, right? The weight is just a scalar, just a real number, and we're going to multiply it by the value for the corresponding feature. Okay. Cool. Right. But yeah, like that. This is a linear model, which means that as you increase or decrease, or as you change any of the features, the output changes proportionally, right? It changes with a linear, it changes proportionally to that change. Okay, so you can imagine like this is a simple model, and yeah, it is. Like this is a really simple model. This is like the building block of what we'll get onto in later sessions for building much more complex models from this. But you can imagine like, well, in real life, house price isn't going to be linear. Isn't going to have a linear contribution on this. The number of rooms in a house. Well, if it's got 1,000 rooms, it's probably not going to be, it's not going to continue being worth so much more per every single one. Also, what I've actually left out on this equation is that so imagine the house has no rooms and it has what did I say this one was? And it's brand new, right? So it's both x1 and x2. Imagine it's just x1 and x2, just looking at two features. Imagine they're both 0, right? Well, we've still got this plot of land, even if there's no house on it at all, right? So it's worth something, which means there should be another term in this equation, which will be a plus b at the end, plus some bias, because that's what it's worth, even if all those features are 0, all right? So we have this function, which maps input to output. And what that is, we call that a model, and it has parameters which are the weights and the biases. So we're going to keep talking about models, and what that means is, well, the reason we call these functions models is because we assume that there is some perfect function which takes in all the features of a house and outputs the exact correct price, right? We assume that exists, and what we're trying to do is we're going to model that function. And the way we're going to do that is by learning these weights and biases for this function, okay? Any questions about that? Yes?
Do the weights have to sum to 1, or is there...
No, they don't have to sum to 1. They can be whatever. Okay, so...
Are the weights a function or just
weights are just a scalar, so it would just be a vector in this case. So yeah, like if we look at that vectorized form of the equation there, what you got is that's a matrix of examples and a vector of weights. So this matrix has, I think it even says it up here. Yeah, so we've got so just to explain that in a bit more depth. Like I said, we've got a vector for each house, right? A vector of examples for each house. Let's say each of them is n-dimensional, and we've got m different examples. We have what's called, or what we call a design matrix, X, which is a matrix of all of our data, right? So it has the dimensionality so this means X is in the space of real numbers with n by n dimensions, okay? So we got m, can't remember which way I've drawn it around in this place, so we've got m rows. I don't like that terminology anymore, actually, I don't think, but imagine we've got each example in a matrix is a different row, and the number of elements in each of those vectors, in each of those row vectors, is the number of features we have about each example. Okay, so we have that m by n matrix, and what we want to do is multiply each of those features by a weight and get out an m vector, right, which is a vector of predictions for each of the m examples. And so we need a weight matrix which is size n. Okay, so the design matrix is m by n multiplied by a vector of dimension n. The inner dimensions of the number of features match, and then we get out a column vector of m dimensions, which is predictions for each example. I wish we had an example for that. Yeah, something like this. So, bigger. That's a better one. Yeah. Okay. Cool. It's so small. Okay. Cool. So look, this is what I'm talking about, right? We've got this. We're going to get a vector of predictions, right? Sorry, they've got the opposite terminology here. Better one. Okay, fine, this is all right. So we've got n predictions. Imagine n is the number of examples just for this diagram. And what we're going to do is we're going to it's not even a good one. Sorry. The first one was best, I think. Forget that column of ones, you don't need it. That's not even good. Yeah, people put that 1 there, so you don't need to have a biased term, but they've also got a biased term there anyway, so sorry. I will find that and I'll put it in the in the notebook. But for now, where did that go? Okay. So basically, I can draw it. Sorry, people on the. I'll put it in the notebook later, so you'll be able to see. But basically, we have a matrix of examples and a vector of weights. And the vector, that vector of weight, is distributed across every feature of that example to make a linear combination. And we get an output vector which has, as many elements as we had examples that we passed through that function, and each of them is the prediction of the label output. Okay, so essentially what we're doing is we're doing this matrix multiplication with all the right dimensionalities so that we get a prediction for each example. Okay. Now we want to learn what those weights are. So we are going to initialize the weights randomly to small random numbers, usually from a normal random distribution, and then we are going to try and optimize them. The way that we're going to optimize them is by using an algorithm called gradient descent. So I'll find a picture of this in a sec, but what we're going to do is essentially we're going to make a hypothesis for each example, which is that weighted combination, and then we're going to find the difference between that and the actual label for that example, example I. Then we're going to take the square of that, we're going to take the square error for that term so that it becomes positive. And then we're going to average that over some number of examples. Okay, so this is how we calculate how bad our model is doing, right? Using the mean squared error loss. And then what we'll do is we're going to try and find a minimum of that function. So that function, it might be, at some point it has a minimum. And what you want to do is move the parameters such that the value which you're achieving for that loss is at a minimum, because this hypothesis is a function of those parameters, right? Of those weights. And so, we'll try and update them so that we minimize the loss. So what we're going to do is we are going to we're going to evaluate that loss function, which looks something like this. We're going to initialize our weights in as many different dimensions as we have. So imagine this is like more than just a one-dimensional weight space. We're going to look at the gradient of the loss function, which is this blue line there. Well, the loss function is a blue line. We're going to look at where we are currently. So if we initialize the weights here, we'll start off with an error of this much, okay? And we're going to look, okay, well, what's the gradient at that point of the loss function? I.e., if I change the weight, if I increase the weight, what would happen to the loss function? If the gradient's positive, then it means that increasing the weight, i.e. moving it in this direction, will increase the loss, right? But we want to reduce the loss. So what we're going to do is move our parameter in the direction which is opposite to the gradient. So we'll move in the direction of the negative gradient, such that we step from here to here, to here, to here, to here, iteratively, so that we're moving down and descending this surface, right? That's the simplest diagram you can get of it. And that can happen in many more dimensions as well, right? So what's happening here is that, you're starting up here, and then you're following the gradient downhill, okay? So we're just taking steps down like that. And until we arrive at some, ideally, minima. Is there a question?
How do you know that that's like the actual minimum and not just like a local?
Yeah, so you don't actually, we might not actually know that is a local minimum. What you'll see is that, well, you can do testing, so you can evaluate on your data set how well is it actually performing, and then you can compare that to, well, what application is this and what kind of error do I actually need? If it's a sufficient local minima, then that's all right. Otherwise, you can keep trying to get better local minima. But this is a really simple model, right? And like, you don't really want to use this for anything real life. And so why I'm teaching you this is to build on top of it, to build neural networks in later lectures, right? And what you see with neural networks is that the space of the weights is so high dimensional that the probability of finding a local minima rather than a saddle point decreases exponentially as the number of parameters increases, right? So what you end up with is that local minima, everyone thinks, oh, that's the problem. It tends to not be a problem. Yeah, because the weight space is so huge, okay? And, it's unimaginably many-dimensional. Okay, cool. So what we're going to do is we're going to use our loss function to evaluate the surface. We're going to look at the gradient on it, and then we're going to move the weights in the other direction. That's linear regression, okay? So, yeah, let's do this then, all right? I don't know what the best way to do this is. Sorry, I'm just going to get something up. Okay, cool. Right. So what I suggest then, I didn't bring another screen, so I can't duplicate this now. But I'm just going to walk you through this. Okay. So if you go to Colab and follow along, try and implement this. Well, I'll explain exactly what's happening, and then you can get hands-on with yourself. Okay. So first, we're going to import NumPy. So this is the first case we've seen of using a library, right? So this is a library for doing matrix multiplication, and we can import it and then just give it a new name by saying as np. Okay. Another library we're going to use is matplotlib, matplotlib.pyplot as plt. So this is for plotting and this is for computation. So what we're going to say, just in this function here, is we're going to make m data points. So we make a function and we call it make data, and then we give it the number of data points. And then we're going to use this thing called NumPy linspace to make the default. So we're going to make m different linearly, like equally spaced points between -10 and 10, and then we're going to reshape that into a size -1 by 1. Okay, so let's maybe doing this. Yeah, I don't just want to be reading out for you guys. It's not much fun. So I won't code this function because it's relatively simple, but we'll just go through it. So what we're going to do is we're going to reshape our x into a vector rather than just a, so we can see, print x dot shape there. Then we will make data m. Okay. If we run that, God, what's happening? Okay. Okay, cool. Look. So here is what our data looks like. It looks like an array like that. Sorry, I'm just losing track of which one's which. Okay, yeah, so sorry, this is what we get returned from that, basically. But essentially what we're doing is we're creating a list of numbers. We're reshaping it so that it has, so this -1 means I don't care how many rows it has, give me as many rows as there are, but make it have one column, which changes it from a list into a vector. Then we're going to have this list called coefficients, which are going to be the coefficients for different polynomials of that data. So we're going to take the data we've got. Essentially, what this function returns us is the vector of inputs we have. So this first one will be x. So we'll have 2x minus 30x squared plus 0.5 x cubed plus 5 x to the 4. I think that's the function that we're going to try and model. And so we just get we return the evaluated x with those coefficients to make a function. Okay, sorry, that's a bit confusing, but we'll get on to the actual important stuff now. So now we're going to make some features, and no problem. Yeah. What's happening here? Okay, cool. So here we've got a list of the powers of inputs which we want to include as features. So we're going to make up some features, right? Just to print the number of features, we make this variable called n. And then what we'll do is run a function which takes in those powers, and it will make features from the data we've got. So it will take in a vector of x, and it will return us like a matrix of features, which, as I said, has m different rows and n different columns, and in this case those columns are going to be x squared and x cubed. And this basically is just making that, it's just a helper function again. It's commented. I think we're going to run out of time, so I won't go through that in depth. Now we get the features, and what we need to do before we pass them into our model is scale them. So one problem that you might have is that some features might be on a much larger scale than others. So for example, if you're looking at house price, the number of square feet in the house might be on the order of hundreds, but the number of rooms is only on the order of less than 10, right? So what you get is that, well, if that number which is on the order of hundreds is contributing to my output, and I also have a number which is just on the order of less than 10, then the larger number is going to contribute much more to the output. So what you need to do is to put them both in the same range. So otherwise you get what looks like a really stretched out loss function. So feature scaling, look at that. So if this is a contour plot where each line is at the same height, this is what our data might look like before it's normalized, right? So it varies a lot in this direction, and these higher points are very far away. So the gradient is pointing right into the middle, and so in this direction, this is where we'll make large steps. But in this direction, the gradient is much lower because it changes over. Sorry, it's much higher. We'll make large steps in this direction, but not in this direction because the gradient is more spread out across there. So if we don't scale our features, what ends up happening by following the gradient is that we take really big steps all the way across this valley, but not directly into the center, okay? So optimization tends to take a lot longer. So if we scale our features, that is by putting them on the same order of magnitude, by like dividing by their range, so they're all between 0 and 1, then what we'll have is a loss function which looks much more like a bowl rather than a valley. And now now you can see these contours are much more even in either direction of the weights, where these are the different weights, and the height of this surface is the loss. So we'll move into the into that center in a much cleaner way if we scale our features. So the way we actually do that is by taking our features, getting the mean of them, and then getting the standard deviation of them, or the range, then taking those features and subtracting the average from them. Then we'll divide all of them by their range, so that they're all now between 0 and 1. And then if we print them, so if we run that, we just made that function there. But what that's going to do is put our features on the same order of magnitude, so they're all between the range 0 and 1, which means that they're not going to contribute disproportionately to the output by being on different scales. Okay. So let's actually do something interesting. So what we're going to do is we're going to go over the whole data set for a certain number of times and take steps by evaluating the loss at each of those for each of those batches of the data set. Okay, so we're going to say firstly our epochs is equal to 100. Epochs is the number of time that we're going to go through the whole data set. Okay, and sorry, I didn't explain the learning rate up here. Is that not in the I'll put that in there. Okay. Okay. So what this means is the gradient of the loss. And what we're going to do is we're going to go over our examples for each item in our data set. We're going to take the weights, and we're going to set the weight equal to the weight minus some small step in the direction of the negative gradient, right? So in the opposite direction of the gradient, that's what that negative for, is we're going to update the weights in that direction by some small proportion. This proportion is called the learning rate. So if we have must be a good diagram for it here. So we're going to take tiny small steps in this direction down here, right? And the size of those steps is controlled by this learning rate here. This is what I was looking for. So if that learning rate is too small, then we're going to move in the direction of the negative gradient, that is downhill, but we're going to only move by very small amounts. If the learning rate's too high, then when we're here, or say we're down here, we're going to move in that direction towards the center, but we're going to move by a lot because this is controlling the step size. So we might jump all the way over to the other side and then all the way back and then diverge instead of converge. So we don't end up just stepping down nicely and converging. We'll just go flying off. So yeah, so what we want to do is figure out by trial and error what learning rate is causing my loss to decrease over time. So this is the equation we're going to use to update our parameters, and that's what we are specifying here. So we're going to say that the learning rate is 0.5. So when we find the gradient is, say, 10 at a certain point, what we'll do is we'll step by 5 in the direction of the negative gradient. Or, well, if the gradient was 1, it's proportional to that. And then we're also going to define the batch size equal to 32. Okay? So that's basically how many examples do we want to look at once. So stochastic gradient descent is different to gradient descent or batch gradient descent. So gradient descent is where you look at the whole batch at once, all of the examples you've got, and then compute the loss for those examples, for all the m predictions, and then also compute the gradient of the loss for all of them. But if you're doing all of them at once, that means you have to pass all of them forward through the model, which means that it's going to take a long time to get any predictions at all, at least much longer than it needs to. So what you could do instead is just pass one example through, and then find out what the gradient for that example is. The problem with that is that you're only optimizing for one thing at once. You want to be optimizing for the whole data set at once, right? You want to be optimizing for the full batch, but that's going to take so long. So you want to do something between full batch and single example gradient descent. So we do mini batch, or otherwise known as stochastic gradient descent, which is where you take a batch of examples, pass them through the model, evaluate how badly the model has done on those examples, find the gradient of that loss function, and then move in accordance to the step update, which would improve the model for those examples, right? So we're going to define a batch size. I'm going to define a class linear model. And what do we need to do? Well, we need to initialize this. And we're going to do so we define the initialize function, and then we'll do self.weights is equal to, we're going to initialize some random weights, right? So we use that library NumPy we got to create random weights from a random normal distribution, randn, random normal, and we'll have, we already defined this number n, which is the number of different features we're going to have, i.e. the number of different powers of our inputs in our data set. So we're going to do n by 1. That's a vector of weights. And then we'll also do self.bias equal to, similarly again, np.random.randn n by 1. Sorry, yeah, that's just 1. So because we're taking a contribution of all of these different features of our data set, so like in the house example, it might be rooms, doors, that kind of thing, the number of them. We're finding weights for them, multiplying them and summing them up into one number, and then we're adding some bias, some offset. In our case, what we're doing is we don't have lots of different features for our example. We just have one input, but what we're going to try and do is make different powers of that input, so x squared, x cubed, and then make linear combinations of those powers. So that's what we were defining here in this function. We're defining, okay, in this case we're going to use x squared and x cubed. So now we've got our weights and our biases in our model. What we're going to do now is define how to do a forward pass of the data through our model. Okay. So this needs a self. It's referring to this class, this instance of the class. Then we'll do a forward pass of the through the model of the data. So we're going to take an example, right? It's going to be a vector of size n, and we're going to do a matrix multiplication np.mapmul of our x with self.weights, right? So we're going that's taking a linear combination of them, and then we'll do x plus equals self.biases. Okay, so add the biases to to the linear combination, and then return us that x, which has now been transformed into a prediction for the output. Okay. Any questions about that? Linear combination, and then add the biases. Okay. What I'm going to do, yeah, so I just formulated it differently down there. So that's our model made, right?
Sorry, is there any particular reason it needs to be from a normal distribution?
No, it's just initialize them as small, so they're all on the same scale, and yeah, just random. Yeah, but you don't want to set them as all one thing. Note that, because if you set all of the, so say you initialize them all to 0, right? Then what you do is you'll output a prediction, you'll calculate the mean squared error for that, and you'll find that the derivative of your loss, i.e. the gradient, in direction of all of the weights is the same. So you'll be learning the same thing for all of the weights, which means, like, well, you may as well just be learning it for one of them, right? And then you're losing, yeah, you'll be losing capacity from your model, how complex functions it can represent. Sorry if I'm going a bit fast. We're a bit late. I didn't expect this to take so long to go through. It's all commented if you have to go and leave later, and also there's you can get in touch with us about it. But otherwise, yeah, we're going to keep going. So we defined our model, right? Now what we're going to do is walk through defining our loss function. So the loss function is the mean squared error, right? And that's going to take in what we predicted, our hypothesis, and our label, y. Then we're going to calculate the difference. So say the difference is h minus y. And that's the difference between two vectors, right? So we've got a vector of predictions and a vector of labels. We're just taking the difference between them. And that's a vector of differences. And then we'll say that the loss, commonly denoted as J for some reason, is going to be np.matmul. So matrix multiplication of the differences together. So that's basically a way of squaring them. So yeah, I mean, we could also just do np dot power diff to make it a bit clearer. Sorry, this is an introductory session. So np.power diff 2. So that takes all of these differences to the power of 2, squares them, okay? And returns something the same shape. And then we can return, we should just be able to return j. Okay, cool. So we've defined our, any questions about the mean squared error? Okay, so what we're doing is we're just making a prediction. We're taking we're subtracting the label, and then we're squaring that difference, and then we're returning that. And now we need to determine. Now we need to make a function to do the stochastic gradient descent. So just to walk through this one, what it's going to do is going to take data in, and of a certain batch size. It's going to sample randomly. So we'll do np.random.randint. So this is random integers in the size, yeah, from like, so up to the maximum number of examples in our data set. That's m. So basically choose a random index from our data set, and how many of them? Well, choose batch size, right? So get some random integers to sample our data set with. In this next line, we're taking our features and the labels, and when we're getting the data which we've brought into this function, and then we're indexing it with those samples. So this sample will be a list of indices, and when we pass that to our data, it just returns us the data at those indices. And so here we can, you might not have seen this before either, this is like unpacking two different things in one line. So I've said, well, do this thing, so get this sample from the data, and get this sample from the labels. Separate them by a comma, so it's going to return two things separately, and I'm just going to assign them to two separate things, right? So the features for this batch, that is all the information about the examples, and then the labels, what we should be outputting for those. Then we're going to make a prediction, which is calling this myModel.forward function on those batch features, right? So what does that do? What that does is comes to here, linear model which we made, calls this function. So it takes a weighted combination by doing the matrix multiplication between the inputs and the weights, and then it adds the biases, okay? And then what we're doing is we're using the mean squared error function that we computed to to compute the mean squared error, which we wrote to compute mean squared error, to compute that between the prediction and the batch labels. So what did we predict with our model, and what did we actually want to get as a label? Okay. And then we're calculating this dj/dw. So this is the rate of change of the loss with respect to the weights. And the way that we calculate that is using so that's what we're doing here. We're calculating this dj/d weights, and we'll also have dj/d biases. And the way we're doing that is by taking that mean squared error function, which is differentiable. So I'll draw this on the. I'll add this in the notes as well later. Sorry, I should have put that there. But the derivative of that is basically going to be, so it's 1 over m multiplied by h minus y squared. The difference of that is going to be the derivative of that is going to be 1 over 2m y h minus y. Okay, I'll put that in there later. But that's what we're computing here. So we're going to calculate that that matrix multiplication where you have the features multiplied by this part, averaged over the batch, divided by m. And then we're going to get the weights of the model, and we're going to subtract from them the learning rate times that rate of change. Okay? So this is how the loss changes with respect to the weights, and we're just going to move those weights in the direction, in the opposite direction of that gradient multiplied by the learning rate. Okay? We're going to do the same for the biases, and then we're going to return the cost, which is this mean squared error, just to see how bad the model is. Okay? So now just the last thing is to write a function to train the model. Okay? So we'll initialize an empty list of our costs, and then we will so we're going to go through the data this many times, right? This epochs is a number which we defined above, and we're going to go through each of them and call the variable e at that time. So every time we do this, we'll print the bias and we'll print the weights just so we can see what it's doing, and then we'll evaluate the cost by doing stochastic gradient descent. We'll return the cost from that stochastic gradient descent, but that also updates the weights of the model. Okay. It's also it's adjusting the model parameters such that we should be moving towards representing a better function to map our inputs to our outputs. We'll calculate that cost, and then we'll add that to a list just by doing .append cost, and then we will print that epoch and that cost. So that's the training function. Okay. Any questions about that? How that's happening? That's basically the whole algorithm there, right? So it's like we take data, which is in rows in a matrix. We have our model, which makes linear contributions of those features for each example. Add a bias, that's our prediction. Then we're calculating the loss for that example, which takes the difference between the prediction and the label. And then we're differentiating that loss function with respect to the weights and the biases to find the gradient. And then using that gradient, we're updating the weights in a direction which should minimize the loss. Okay? And then we're just doing that repeatedly for different batches in here and over the data epochs many times. Okay, any questions about that? Okay, cool. I'm probably losing people, sorry, but let's rush this. And then we'll return the costs. So, and here this is like where we're running it all, right? This is just like calling all the stuff we made earlier. Make features is not defined because I haven't run out at the top. Okay, cool. So there we have all that stuff that we've printed. Can't remember what all of it is in the functions, to be honest. And now we're going to create the model. Okay, so here's that class that we made earlier, linear model. And we're instantiating it like this. Make an instance of it, and then we'll run the training function, and that'll return us the costs. Okay, so it's a really simple model, so it runs super quick. And then what we'll do is, this is just plotting stuff for setting up a figure. If we run that, data in is not defined. Do we lose that? Okay. Yeah, I think you're right. Normalized underscore data. Nice. So we could plot this live as well, but it's a bit more difficult to do in the Jupyter Notebook. But this is what's happening. Sorry for all of that with no visualization. Apologize. Get to the end here. What we have is, like, these are the inputs which we had to our model, right? So this was some function that we made. And now this is our hypothesis, which we've learned over time to try and fit that, okay? But this is only using second and third powers of the input, which is what we defined just down here. So if you change these, we'll be able to see how the function changes. Should be able to. See there, like, it's nowhere near as good of a fit, right? Because we're only including, like, our inputs to the power of 1 and our inputs to the power of 3. We've lost, like, some quadratic expression from this from our function. So if we feel free to, like, play around with those functions, and there's all different kind of hyperparameters that you can adjust here to experiment yourself, like, with what's actually happening here. What's how is this function changing as we include different features to our model, like different powers, different numbers of powers. If we change the batch size, if we change the learning rate, and you'll be able to visualize how that prediction changes. And what I've plotted on the right here is for each batch in this direction, what's the loss? So you see, like, it's really noisy here and it doesn't even get that good, but here, ideally you want it to be going down, right? And this is like the classic thing you'll see every time you're training a machine learning model is this training curve. You want it to be obviously going from high down to low. And once it reaches a sufficient low level, then you should be able to be getting a good input-output representation of with your model, right? And so that should be problem solved, whatever that problem be. So that is the end of the notebook. I'm sorry for the rush. I think that should have been a longer session. I would have gone through and I would have coded the stuff myself and explained it better. However, it's all commented. That's all filmed. And it's all available online just through the Hacker Hustle link. If you have any questions, feel free to come and talk to me now. Put them in the chat, although I think we're all going to leave the chat after this meeting. And I hope you learned something. I hope you learned some Python at least. Yeah, I'm sorry that was rushed at the end, and we'll go through that more clearly in the next session, which will be Introduction to Machine Learning. So what we did there was basically a chance for you to code that stuff, make some more classes, make some more functions, and actually get like a basic machine learning model working from that. But if you're interested in learning actually what's happening, like why are we using the mean squared error, for example? How can we use more complex models? What can we do with our data to actually be able to like represent more complex functions than we have the data to represent by like augmenting it or generating it, that kind of thing. If you want to learn more about that, then next week we are running an intro to machine learning class, which will be hands-on and implementing, basically teaching you about the 4 main things you need for building machine learning models, which can be anything. As long as you formulate your data correctly, write that, and you build a good enough model, after that session you'll be able to build neural networks that can do much more complex stuff than these linear models can represent. See how this is struggling already here. With that, if you are interested in coming along to learn more about that, then just go to the site, upcoming events, and then you can follow either of these links here, okay? So they'll take you to Eventbrite's where you can sign up. So this is what we're planning now. Let me just explain like what this is about, right? So we've been teaching for a while, and we were running something which became like a bit too corporate really, and was focused on like working with companies to work on their boring projects, and struggling with all the bureaucracy behind that. But really, like, what we wanted to do was just teach people and work with people to make cool stuff, right? And so, and we think like AI could be like a real engine behind all of that. So if you're the kind of person who like wants to get involved with like learning how to do this stuff, making AI, making things which can solve really interesting problems, like some of the stuff we're listing down here, then like we want to have you on board, and we want to create like a team of hackers who can work with us to build cool stuff, right? We're going to be holding workshop events like this to give you the skills you need. We want to know what you guys want to learn, so if you can let us know. I just realized I don't have it on there, but I'll put on the main page a feedback form. What you want to know, like, please let us know it, and then we'll teach it as it comes along. And then, other than the workshop stuff, what we're going to be doing is like holding weekly sessions to get together and like build stuff. So if you're interested in actually coming along and like sharing what you know about deep learning, or learning from one of us, or actually trying to build something which we can throw up on the internet, like I did this site last night, then let's have you along. So I'm gonna stop ranting. Sign up for these events, and I hope you learned something, and I guess we'll see you next time. Only other thing is deep learning office hours. If you've got any deep learning problems, you want to talk to someone about code setup, debug, anything, solving a problem, click here and you can sign up for a video call with any of us, and we'll go through what you need with you. Okay? Cool. Thank you for coming. Let us know what you think. All right. Thanks, Twitch.